Exam preparation notes, measuring frequency, digital frequency meter, a visual study guide for electrical instruments. Today, I am breaking down the what, why, and how of digital frequency meters. Let us learn. To know this, you have to watch till the end of the lecture. The evolution of measurement. Mechanical oblique analog relies on physical properties, that is weight and dimensions. Accuracy limited by physical construction, that is half cycle. Digital or electronics relies on logic and timing, that is pulse counting. High precision based on exact time intervals. Next up, how do we count invisible electrical pulses? To know, you have to watch till the end of the lecture. Entering the digital world, the toll booth concept. Digital meters work by getting an unknown signal into a counter for a specific time, usually on second. Unknown signal pulses. When the gate is up, that is high, pulses drive through and are counted. Gate enable signals. When the gate is down low, pulses are stopped, that is, do not enter the counter. Please stay with me till the end of the lecture to know more important and interesting things. The block diagram walkthrough. Input signal of unknown frequency. Attenuator and Schmitt trigger cleans up the unknown input signals and then put into the AND gate. On the other hand, clock oscillator and driver generates gate enable signal. Generates the gate enable signal, the stick timer. AND gate, the intersection input acts as the clock for the counter advancing on count or transition. The AND gate is the heart of the system. It needs both signals to pass the pulses. Counter clock made of cascaded binary coded decimal, that is BCD counters, and then decoders or display unit converts BCD logic into the normal decimal numbers for us to read. If you have found this breakdown helpful, hit the like button for more deep dives into the world of electrical engineering. See you in the next one. Digital logic, gating and waveforms, unknown input signals, gate enable signal, high and low level. Gate enable goes high, the door opens, unknown pulses pass through and are counted. Output between T1 and T2. Example, if gate is exactly 1 second and counter sees 600 pulses, then frequency is 600 Hz. If you have enjoyed it so far, wait for a moment because the next points are about to get even more important. Side by side, mechanical versus digital. Mechanical read type and digital counter type. Number one, natural physical resonance matching and electronic gating and pulse counting. Number two, vibrating painted flag and LCD oblique LED decimal display via binary coded decimal decoder. Number three, half cycle gaps depend on tuning, highly exact depend on clock oscillator. Number four, low electromagnet plus metal strips. High for digital counter type, logic gates plus drivers plus triggers. Example trip. If the question asks for robust and simple AC system, think mechanical. But for exact precision, think digital. By watching this lecture, if you feel that I have provided any value, please subscribe my channel DCD Electrical Knowledge to get even notification of next coming video. Thank you.